right, our first speaker is Pat Riddell. Pat is a licensed civil engineer and construction manager here at Cannon. His experience includes grading and drainage analysis, stormwater hydraulics, utility design, and preliminary site planning and permitting. As an engineer as well as a construction manager, Pat brings his vast design experience to the field and allows for a higher level of constructability. His project experience includes projects such as the Phase 4 Pismo Promenade, Highway 46 and 101 interchange improvements, ISFAC facility at Diablo Canyon, and 21st Street improvements in Paso, which is the first complete and green street in the county. Pat is a graduate of Cal Poly San Luis Obispo and a longtime SLO County resident. So please welcome Pat.
Good morning. Quite a turnout. Just want to say thanks for all of you showing up today. What I did was put together a presentation broken into 4 components. It essentially follows the handout that you'll receive at the end of the seminar. Follows basically cost estimating, grading components, the landscaping components, and we'll get into quite a bit of the excavation, because I know a lot of people have had trouble with the excavation issues and just really understanding the details. So again, the goal of the presentation really is to provide pointers to help contractors and developers navigate through the LID projects, better understand the details and really what the intent is of the LID features. One thing to note is that the LID features really are a different type of construction. They might look similar to standard features, for instance, standard curb and gutter. And so once these projects are complete, when you look at them, they look just like your normal roadway improvements. And really, there's a lot of stuff happening that's underground. You've got deepened curbs, upwards of 3 foot deep, or cut-off walls. We've got retention basins. And really, we'll kind of discuss the functionality and really some of the issues that I've seen in the construction process. And then, sorry. And then some of the key differences in understanding the differences between those components. So one of the first steps, obviously, is reviewing the plans and specs, and the contract docs. It's pretty common. That's pretty obvious. But really, you want to get into the details, and so really look for those LID components. It'll be really important to review the plans with your subcontractors, because depending on how the project's been divided up, whether you've subcontracted out your concrete work or some of your grading work, it'll be really important at the beginning of the project to get everybody together, really understand what the intent is for the LID features. Because a lot of times what we run into is the prime contractor will be completely up to speed, know exactly what they need to do and how to get these things built. But a lot of the subcontractors aren't aware of a lot of the issues, such as protection of the LID features. So they'll come on site, they won't be familiar with where these features are at. So it's really important at the beginning to get everybody coordinated. And then also to ensure that your vendors are complying with the specs. So what we've run into there is that they may not quite understand they'll think that if their product is close or similar, that it's going to be acceptable. A lot of times, they're very specific products, so it's really important that the vendors understand that there isn't much flexibility in the LID components. And one thing I want to point out on this photo, this is actually a really good photo showing the excavation. We'll come back to this later, but in this photo you'll see that there's a utility right across the trench. And you'll see off to the left of the trench there's some sand material. So these are the kind of when we'll talk about how you would protect this later, but that sand, normally your utilities are sanded, the trenches are sanded. These are the types of things that you really need to look out for when you're building these LID features, because these will fill up with water. You obviously don't want your water channeling down these utility trenches. So a little bit later in this presentation, I'll explain how those get protected along those vertical cuts. So again, the LID features, they require special construction considerations. This is just a quick detail showing why these things are different. You basically have a cutoff wall essentially at your curb line. It's, it could be anywhere from 24 inches to 42 inches sometimes. And when the contractor's putting together their estimates, they really do need to look at, where are these things located? Because I know a lot of times to save money, you might look at, if I've got hundreds and hundreds of feet of curb and gutter, they may be looking at doing an extruded method. But if you have these features intermittently between your extruded curb, it may not be cost effective to look at the extrusion method. Again, they're going to require a little bit more special form work and compaction work around them. So again, it's something you really want to pay attention to as you're going through the plans. You want to look at each LID detail. So as part of the estimating process, I think a lot of times what happens is the contractors won't look far enough ahead and what they need to do to protect these features through the whole course of the project. So really at the very beginning of the project, you're going to identify where your LID features are located. And then through the project, from start all the way to the end of the project, you're going to have to be protecting these features. So there's going to be a cost associated with that. You're not supposed to be driving over some of these features because compaction's really a critical aspect. And so whether you're establishing defined routes, putting up fencing, the photo on the right actually shows how this particular basin was fenced off. The photo on the left shows how we're having to protect from stormwater runoff. But again, I mean, this is something that's going to happen all the way from the very beginning of the project all the way to the end of the project. And so a lot of times what happens is a facility is constructed, and then the thought of what you're going to do with the facility in the interim really isn't considered during that bidding phase. So really we just wanted to touch on that to make sure that you do look at those additional costs. So some key considerations for successful transition from bidding the project and the design of it into actually constructing the project. Obviously, you're going to want to look at the potholing requirements. A lot of times there'll be a potholing item, whether it's a public works type project. If it's more of a private development project, you're going to want to look at how you're going to address identifying all of those utilities, because many of these LID features require excavation. You're going to want to know where those utilities are early on. So you're going to want to make sure that you're not going to have conflicts 6 months into this project with the utility that was on the plans or USA'd at the beginning, but didn't really look to positively identify where that utility was until you were pretty far along. So, identifying the conflicts, verifying the design assumptions. Again, it's one of those things where you want to ask as many questions as you can at the very beginning of the project. I think right now, with this being such a newer concept, everybody's really involved and really interested in learning about the LID component. So beginning of the project, ask lots of questions. And I think ultimately that's going to help understand how these things are implemented. And really, if you don't understand how they're working, it's going to be difficult to construct it. And I think just having that understanding is really going to be beneficial. So some other issues we ran into are long lead times. The bioretention soil mixes, I know that there's maybe only a few suppliers that are doing certain mixes, so it's something that you want to look at ordering really early in the project. Anything with really long lead times, you're going to want to look at securing your vendors, making sure that they can deliver the specified product on time. Really, any of the special items that need to be fabricated, I mean, all of those things really should be looked at the very beginning of the project. Now, if you're doing a public works type project, that should be spelled out in the order of work. If you're doing a private development, maybe not quite as clear as to what products are going to take a little bit longer to order, but those are definitely some critical items you'll want to look at. So here we provided an example of the photo showing a basin, and the basin hasn't been dug yet. And so this ties into the actual staging of your work. And so by not digging out the basin, you're able to allow equipment. You're not really having to worry as much about the compaction requirements of the basin itself. And then you can actually work on the excavation from the adjacent paved surface. And we'll talk a little bit more about the compaction requirements, but these basins really are, the whole intent of these basins is to promote infiltration. So by keeping heavy equipment out of it, that really is going to maintain those infiltration rates. And that's really one of the big requirements of the LID construction is either improving those infiltration rates or at least maintaining your native rates. So again, this is something that in building it, you're going to want to stay out of these areas, work from the side. So it might be effective to just not touch them, build everything around it, then come back at the end and build all of your LID facilities at the end of the after all your paving and flat work is complete. So again, on the staging and scheduling, we included a couple photos. The photo on the left is actually some permeable pavers. And so the joints are what are used for the actual infiltration. And so if the pavers are installed too early and you're running equipment back and forth on these pavers, what's going to happen is you're going to end up with siltation within these pavers. So you get towards the end of the project, now the pavers aren't working as the design intended. So you're going to have to come back, you're going to have to either redo the joints or you're going to have to vacuum the joints out. I mean, it's an additional cost and additional time that you're going to have to spend on the project. So it's really these are these little components that you want to look at and make sure that you're understanding how these LID features work. And then you want to stage all of your construction around that to best protect those features. And then again, on the sequencing of the work, once your LID features are completed, especially the bioretention areas, you're going to want to plant those as soon as possible. Really, they're dependent on the plants establishing themselves. So say if you were constructing the project in phases, I know a lot of times what happens is that we want to wait to the very end of the project, the landscaper comes in and they landscape the entire project. Well, with these LID features, it may be a little bit more beneficial to come in and landscape a portion of the project to really try and get some of those features established early on, because in the long term, it's going to save you time and money on the plant establishment period and the actual maintenance period. So here's a photo showing the protection of an inlet on an LID feature. So the photo is actually showing a curb cut, and what's happened there is there's been some gravel bags packed inside. You're going to do a lot of this protection through the course of the project. Really, that upstream drainage is what you want to keep out of your facilities, because ultimately, if you're letting them into your facilities too early, you're going to be dealing with not only maybe some of the sediment from your project, but the facilities aren't going to be performing how they're intended. So really, you want to make sure that, again, when you're scheduling your project, you understand which items you're going to be wanting to protect, how the drainage is running through your project. And sometimes the designer will help lay that out for you, but the contractor really is going to have to understand their sequencing when they're building these features. So there's going to be times when you can't actually protect those features. So there might be a situation where the bioretention basin is in a sump condition, and it's the only drain that's allowing water to get out across a road. In that case, you're going to have to let your water into your LID feature. So you're going to need to consider all the temporary measures to protect that LID feature until it's established. We included some of the items that we've identified as possible protection measures. You might want to look at doing a temporary storm drain inlet, covering the facility with fabric. Also, leaving the grade high is another option. We had that photo previously, and so what that will basically allow is for water to come in. I mean, you basically protect your basin, but you're going to let the siltation come in and then basically scrape that siltation out when you're ready to actually start implementing the actual construction of your LID feature. Also, it's really critical on timing for the time of year that you're actually constructing these features, and that's going to play a pretty critical role in the staging. Obviously, if you're going to start construction right before winter, you're going to run into a lot of problems. So again, it's something that needs to be thought through. Make sure that you understand the drainage patterns across your site, and try and schedule your LID construction to minimize impacts while you're actually working on it. So LID features, they're basically different than your standard features. Most of them are going to require some type of excavation, and that's, I think, something that is a little hard to get used to. So normally you're trying to build things to get water away from wherever, get the water down the road. I mean, it's occasionally you're building a basin, but in these cases, you're actually trying to promote water ponding. And that's a little bit different than how construction has gone historically. Historically, you're trying to get it in your pipe, trying to get it down the road into whatever watershed is close by. In these cases, you're actually trying to keep this water on site, create a ponding situation, and actually promote infiltration. So really understanding how these things operate is pretty important to successful construction. Now we've got, there's a photo on the right, there's an inlet, and it's got a storm drain standpipe essentially. The top elevation of that inlet is about 2 feet higher than the surrounding grade. The first thought is like, oh, there's a design bust on this thing. The inlet's too high. So you definitely don't want to just start making adjustments on these without consulting with the design engineer, because there is a purpose behind those inlets being high. Obviously, that's to create that ponding depth. The photo on the left shows a curb around the back side of the basin. Again, that's to create ponding. That's actually the outlet of the structure at the left of the image. So what happens is this will pond up and then it will spill out of that curb cut. So again, these are a little bit different, and really understanding what your ponding depth is, understanding how these storm drains operate is going to be really critical. And the most important thing is to just not make changes to those elevations, because then these components won't perform as they're intended. So we wanted to touch on this really quick, because depending on where you're doing construction, sometimes you might come across, I know more recently, a lot of people tie roof drains into storm drain systems. Just wanted to point out that it's really important that you don't make changes, even subtle changes, to the LID designs. So essentially what we're suggesting is you don't want to take a pipe that maybe was, if you're doing excavation along the side of your road and you come across a roof drain pipe that was outlet to the curb face, you don't want to just tie that into a swale basin off to the side of the road, because that may overwhelm that basin. So again, it's really important to coordinate any of those field changes with the design team or with the owner. So on the left is just some really good examples of the different types of curbs and gutters with the unique details. All of these have the purpose of directing stormwater to your LID features. Most of them are going to be depressed to ensure that they're pulling the water into those features, but they are going to be different than your standard curb and gutter. So really Again, it's going to be important to ask those questions early, identify these details, and then understand what the intent is. The photo on the right, so looks like a normal curb. Well, that curb extends 3 feet below grade. And so with just visually looking at that, you wouldn't know that just walking down the street. But these really are kind of the important components that are not noticed by the general public. So understanding the desired infiltration. So where do you want this stuff to infiltrate? So you have these LID facilities, and there might be some areas adjacent to that LID facility that you do not want infiltration happening. You're going to want to install those protection measures, and those are going to include those moisture barriers, the deep curbs, the under drains. So understanding what you're trying to protect is going to, again, be really important. This photo on the right, actually, again, it's a curb that has a 3-foot depth with a roadway off to the side. We actually have the liner that runs down the backside of that curb several feet to keep drainage, keep infiltration from happening underneath that curb line out into the road. Because ultimately what would happen is you would start having issues with your structural section in your pavement. And so really, you don't want to just eliminate or make changes to those barriers. And the details with those barriers are really, they are very critical. So here's another detail showing an LID facility off to the side. Under drains really aren't used in these facilities very often, but when they are used, there is an intent for those. And so the location of that under drain may not be clear. I mean, it might be at the very bottom in one system, and it might be halfway, maybe it's 2 feet down in one system and 4 feet down in another system. Well, there's an intent behind where those are located. The perforations might be facing up or they might be facing down. Those details really should spell that out for you. And just wanted to stress the importance that there are reasons for the specific nature of those locations. So again, it's one of those things where if there are a misunderstanding, it's better to just ask those questions, understand how this thing is going to operate before you just start making field changes because you think that really this should be lower, like a normal French drain. Filter fabrics, there's been kind of a different thought on the filter fabrics. Filter fabrics used to be used pretty regularly to separate your existing grade from rock. The new thought is that what happens in the long term is this filter fabric becomes clogged. And so I think a lot of contractors are still very used to using filter fabric, whether they're wrapping pipe or they're placing it on the subgrade and then placing their rock over the top of it. So again, there is a reason why there is not filter fabric shown, and it's because really the more recent studies have shown that filter fabric in the long term is actually going to clog and defeat the purpose of your LID facility. So if there's not fabric shown, don't install the fabric. Again, the LID features, most of them require excavation, so knowing where all of your tree protection fencing is going to go, making sure that when you're excavating, knowing the critical root zones, review the specs, make sure that you understand if the arborist is supposed to be on site. The actual trees themselves are a big component of the LID, so we want to make sure that we're maintaining those and not basically killing them with any of our excavation within the root zones. So I wanted to talk about compaction in the LID facilities. You're going to want to look at the actual soils report and the special provisions or the specifications if you're doing a public works project. That's really going to spell out how you're going to address these LID features. Compaction is probably one of the more critical components, and it's definitely one that we struggle with in the field. You're going to want to make sure that the equipment stays out of these features. Once if the equipment is operating in these features, I mean, there's potential for compacting up to 3 feet by just one pass over the top. And then what you end up with is a system that essentially isn't going to perform how it was intended. So it'll be important to keep your equipment out, understand the compaction requirements, basically avoid any kind of equipment inside the facility if you can. there'll be cases where you can't avoid having that equipment in. Say you're doing a really large basin. In that case, there should be some recommendations, but the contractor a lot of times will have suggestions. Again, it's something you should coordinate with your geotech, make sure they're on board, make sure that they're coming out and observing the operation, that they feel comfortable that your soils are not becoming over-compacted. Some of the options are listed, obviously using lightweight or lightweight equipment or light tracks. Looking at possibly placing steel plates is another option. I don't know if I have that listed, but a lot of times you'll see where plates are laid down, and then you can operate over the plate because that plate is going to spread the load out over a much larger area, and it'll avoid compacting your soil. So just moving on to the soil and the landscape, another really important component is understanding the importance of the bioretention soil types. So you don't want to have it mixing with the native soils, so you're going to want to look at using temporary slopes or sidewalls depending on how the actual LID facility is being constructed. You just want to make sure that you're not having cross-contamination or cross-mixing between your materials. This one's pretty obvious. You really are going to want to receive those tickets. You're going to want to make sure that you're receiving the correct bioretention soil or engineered soil. Sometimes there's some pretty specific requirements, so we just wanted to include a short comment on that. Always double check, verify that the material that you're receiving is the material that was intended to be placed. And then Melanie will talk a little bit more about the plant location, but the plant location really is critical. So when you get towards the end of the project or the time when you're actually planting, the actual plant spacing and plant location really is a big component because each plant is going to function in a different way. Obviously, the plants in the bottom or the lowest point of your LID facilities are going to be plants that can survive in a much more wet environment, where the plants up on the higher sides of your LID facility are going to be plants that maybe aren't going to survive in that more wet zone. So really important that the plant spacing is worked out with your landscaper and the landscape architect. Another thing we ran into actually on a few projects is actually doing a demonstration area. So if you have a few similar LID facilities, it may be beneficial to have the landscape subcontractor come out, plant one of your LID facilities, secure approval from your landscape architect or your engineer, which will help expedite planning of the remaining facilities. So during the planning, another issue we ran into was you'll have your LID or your bio areas all graded. And what happens is the landscaper comes in and they start digging all these things up. And you're basically changing the contouring, you're changing how these things are supposed to operate. And again, that goes back to one of the first slides where we talked about making sure that your subcontractors all get together and understand the intent of these LID features. So when you get to the planning, it's really important that your landscaper understands that the contouring of these features is intentional. So when they go to plant, they'll basically be displacing some soil. So you can't necessarily take that soil, place it back in your LID facility. You're either going to have to look at exporting that material or incorporating it somewhere else where you're not going to impact the actual facility design and intent. And we run into this pretty often where the landscaper, again, they come in, they dig their plants, they really don't think through, why is this graded this way? What is the intent? So just something to really pay attention to. So once you're getting towards the end of your project, you're working on planting. That plant establishment period really needs to get factored in. You're going to want to protect these LID facilities until your plants are established. They're not going to function as they're intended until these plants have had time to root. So that interim time, you're going to need to really consider, how am I going to protect these facilities? How am I going to route my water? What is the public perception going to be, because we're going to walk away from this thing? And how are we going to basically maintain these until we can remove our BMP protection measures and allow water into the facilities? So through the course of construction, depending on what type of project, it's going to be important to work through any important verification requirements. You know, the Regional Water Quality Control Board may require field verification of the LID features, either by the municipality that you're working with or a third party through the course of construction. The contractor really should coordinate with the project inspector at appropriate times through the course of the project. I mean, taking photos is always really important. And really those critical times, you know, when you're excavating, obviously that's a time when you're going to want to get your inspector out. I mean, just really close coordination to make sure that at the end of the project, you're not having to come back and dig up any of your features. Maintenance and warranty period, again, that's you want to understand how that works. How long are you going to have to maintain the systems? Is it 6 months, a year? That maintenance period really might include a lot of components too. I mean, there's sediment and debris removal, the cleaning of inlets, the cleaning of pavers. And that should be spelled out in the actual project specifications. But again, it's something that's missed a lot of times. So really understanding what that warranty period is, what it entails, is extremely important. So just real briefly, I'm just going to talk about 21st Street. So the photo at the bottom of the slide, you can see the water is extremely dirty, and so the intent here was to see if we could clean up some of this water before it reached the Salinas River and also promote infiltration. These are some quick points on the project. It was 5.5 blocks of reconstruction. There's 15 bioretention cells, quite a bit of permeable pavers installed. A lot of public outreach, a lot of public outreach on this project. And that was because this was a demonstration project. It's one of the first projects, I think, that was done in San Luis County of this scale. So a couple photos showing the actual process. The photo off to the left is actually the finished bioswale that is actually showing the ponding happening. So this goes back to that public outreach. You can imagine what people are thinking when they first see this. They're thinking, what the heck's going on? This thing is not working the way it should. Why is all this water ponding in there? They think that the water should be draining out. Well, that's actually working exactly as it's intended. At the base of that photo, that's just leaves floating on the water. The photo in the center is actually showing the construction of that facility. You can see how much rock is placed underneath. That is really what creates your infiltration and your storage. And this is the stuff that the general public doesn't see. And again, that's where the public outreach really helps public understand what it takes to construct these and why they're important. And then the photo on the right shows the completed landscaped bioretention area. So this project, the median channel, we ended up with the median channel being constructed at the start of the rainy season, so that created some problems for us. Again, this goes back to public outreach. The photo off to the left, you can see that the channel's dry, but what we had to do was route the water to the street. So we had this is actually an old, a seasonal creek, and it used to be in a culvert, so it was converted from a culvert to an open channel. So you can imagine the misunderstanding from the public when you have that much water running down the edges of your shoulders. So again, that's one of those things where you really want to try and inform the public about how these things operate, what the intent is. The middle photo actually shows after everything's been completed, some erosion protection, the energy dissipators, which are railroad ties, and the water running down the middle channel. The photo off to the right is the completed landscaped channel. Towards the downstream end of the project, there's an infiltration trench. There's a pipe that's about 100 feet long. Again, this is one of those things where you want to understand how these operate, because that pipe is laid in there flat. This actually allows an immense amount of storage. So when you go out there, you won't see any of this, but it's actually pretty impressive, and it works really well. I'm out of time, but at the end of the seminar, you can grab a copy of the technical assistance memo that'll really kind of outline some of the important topics that we'll be going over today, and appreciate your time.